It's still very close to what we have. What we will have on normal SQL query. So, and it's still the same select star. I know last week we saw something like select URL, and somebody was asking, okay, what is the URL? So URL is just like, it's just representing maybe just a placeholder for selecting different columns. So you see, select statements and select record from column starting with a given string. Select string star this. So, and when you want to say limit, now it's possible you say select, if you're using Microsoft Server, MS SQL, you select top 1000. When you're using Oracle, you say maybe select start from table where maybe where row norms less or equals 10. That's what Oracle uses. But in Hive, you see it's simpler. Just put your limits and it's fine. So it says the Hive query language are written to perform database operations. I wish we have access to a database so that we can have a hands-on, and or maybe hopefully when we get to our practical class we're going to be Tim Lola will take us through all this. But I can tell you they are very simple, very, very simple, no big deal. So I said apart from select statement, the other important Hive query are limits clause, nested query, case. Um, Case statement is also an interesting part of a query that you must understand. Case, when, then, this and that. So just like if else statement. So that's what we have on the case. And you have like, and you have the hard like. So when anytime you're using the like function, like it's just as if you know parts of a particular string, you use like, and likewise for hard like queries and queries like group by. So now for group by is a query used for aggregating functions. So for aggregating function, so though currently now on the system I'm working with, I'm having this guy. I'm not having, don't have SQL server. Though I can show you some things, but I will leave it to Tim Lola to take you guys through it. So and nested. So part of queries very simple. You- I I don't know what to explain because these things are too um they are too straightforward. Like your nested query select start from a particular table where you give a condition. So condition can be say where age is less than 10. That will be your condition, and you say your compress, and you select column from a particular table, and that's fine. So when you want to use your case, you can say case where age between 0 and 10, then 10 where age between this and this, then this, else this, end. Give it a column name and you select the table name. These things look, they are simple, but I just want you guys to put it in mind because I can tell you when you get to industry, all these things you will be drinking it daily as if it is normal thing. So you do it every day. So I see your like statement. For instance, now if I know, if I know, say, if I know Oluwatobi's name, so and I'm looking for, oh no, I'm not seeing Oluwatobi's other name. So let me pick say Sunday. So I'm trying to look for Sunday's surname. I know how his name is Sunday. Sunday. And I can say okay, select um first name and last name from a particular table. Let's say students table where where first name like Sunday. So when I say where's last first name like Sunday, automatically it's going to give me everybody has name like Sunday, and I'm going to see okay, his last name is Ogunleye, so something like that. It's always as straightforward as that. So now, so group by. So one thing I see they are not putting here is that before you can use a group by, when you use group by on column one, then there must be an aggregating function on column two. So for instance, now I want to select score of students in a particular class, and or average score of students in courses they took. Maybe in a particular class we have like 100 students, and they all took different topics and different courses, and let's say they took like say 5 courses in all, and I want to find the average score per course. So I can say select course name, average score in brackets, say average open bracket score from particular class table grouped by courses. So now which is column one. So the column one is always a categorical variable. So categorical variable, you understand, since it has levels, so that's fine. So and you're having queries. So you have having queries is that guy is used for limiting a category, a grouping, or let's say aggregating variable. It's also simple. So it's also simple. So I will let's move on to see if we can have a more defined example. No, that means we'll be seeing that coming. I'm sorry, I don't have a table. I wish I can just show you these things are just one of things that we can see and see how we can use them. So, but if I'm opportune to take us through that before we leave, I will. But it's just like we've talked about the query, the group by, and the having is still like time I use it is okay. I can say now I need a list of courses that have their average, the average score is greater than 50. So I'll just say okay, select okay, let me do something. Let me if I can let me just write something. So can you guys see my notepad? Hello?
Yes. Yes, we can.
Okay, okay. So now I want to write a virtual script. So just tell me how to write it. So now if I say so let's start from a particular table. Let's say we are going to have a table. Let's call our virtual table is say class. So now this guy has fields like say name, say uh, yeah, which is say integer. So if we have this now, okay, normal, we can have if you want to select your normal select from so this guy does gives me everybody's first name and blah blah blah. So now so my first that's the first one. So I'm just selecting stuff. So I want to select the average. Okay, like I think there's something like. I want to select. I'm looking for this name, so I can just say So, are we familiar to this kind of queries? They are simple. I know all of us at least one or which one or still. Yeah. So now, when we use the word percentage, we call it a wildcard search. So whereby it's just going to search for everything possible that looks like what we are looking for. So, but sometimes I do something like say lower. It's going to turn into lowercase. Just put something like Sunday. So the output of this guy should give me Sunday's first name or any other person that bears that name Sunday. So it can have a list. So that's fine. So this guy is so, and I would like use details. Okay, so fine. So so if I'm grouping, you just say okay, I'm saying select. I will select. Oh, let's say we have something. Okay, so I will select course and I have score. So what I will do is say average score. So, oh, sorry, I want to grant. Okay, if I add this, so I said um, I, the categorical variable. If you group by, if you don't put group by function, the group by variable, it's going to throw up an error. So this guy is going to give you a list of courses with corresponding score. So let's call this guy earlier and say, so this guy that used to Microsoft Server, something like that, just to give it a name. So that's fine. So now another thing is adding. adding. So now we are still
Sorry, sir. There's no difference between like and I like.
I like okay, it's just they do almost the same thing, but the way you address them are just a bit different. So so this is just how I like does. So you put it in quotes, like though it's in quotes. So it's more like this wide card. It's also a wide card search, but the format is just a bit different. I guess.
Yeah.
Yeah. So
Sorry, sir. Henry is in the lobby, sir.
what do you say?
Henry is in the lobby, sir.
Henry, okay. Henry. I can't find him. Okay. So I think we've talked about group by. So it's just like the pattern of you writing it is just the only thing that is different there. So and when we talk about having, so it's just like something like this. So it's just like okay, select score, the average score from Octave grad class. I can now say having average score greater than 50. So it's just like I want to have courses that the average score is greater than 50. No matter. So that's that. So it's The whole process is just very simple.
But for this average score, I can use the alias also, right?
What do you say?
As you created also, right?
Alias as in?
The average score you created, like the alias as instead of
No,
using this.
no, you can't use the alias.
Okay.
So you must use this guy. You can't use the alias. So assuming you are
And we
running,
can't use where too.
I can't hear you.
I said, and we can't use where too. Where average score
No,
is given at.
you only use having on aggregated when you are working on aggregated function. So now let me assume. So what you guys are saying is this. So let me assume this same query I can write it in two ways. So now I'm writing it with one level script. So if I want to write a two level script, I will do this. So I want to answer both of your question. I can say select select maybe star. So do you know if I should say select star, I'm going to select or let me say this. Let me say this. So let me use star. So it won't be confusing. So when I'm having the second level script, I don't need to use this. I just do from this and close it here. So answering you, so where average score is greater than 50. So these two scripts they will do the same thing. So in this place now, I'm selecting based on the alias, and here I'm using where. But now you see that I'm using a select on the select statement. So that's something you keep in mind. So, but if I want to do it more efficient and time consuming, and just do it once, this guy will give me the same results this guy will give. So instead of me using the having, instead of me using the where, I can use having, and these guys will do the same thing. So that's fine. So type of functions we have built-in functions. So like I said earlier, we have the average function, normal count star. So count star means count everything, and you have your power applying
That is
aggregate.
confused.
What do you say?
It's the next part we can see.
I can't hear you.
It's the next
Okay, okay, you are still seeing my
PowerPoint.
notepad. Oh, sorry. Okay, I think I'm back online, right?
Yes, sir.
Okay. So we have different functions like the count, average, upper means just like the max function. So I also have the arithmetic functions. So these things are basic, and when I mean basic and very simple. So okay, so that's that. So another level we are going to is some defined function. So this is what makes it a bit more interesting and more dynamic than normal SQL query. He said creating user-defined function requires writing Java class and overriding the evaluate method, which is a part of the Apache IFSQL UDF class that is tend to modify the default behavior to evaluate. So 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 in normal as as a normal programming that you have the right to write your own function. Also, you have that in Hive too. This guy also does it. Other structured query language databases like Oracle, MySQL Server, the likes, they do that. So at least I know there are times we need to write a function. to do a particular task, which we call as you will call other functions aggregating functions. So now, what are the steps involved? The first thing is to create what we call the Java class, and so so when you create a Java class, the next thing is create what we call a Java file from the class. So and the script is to say add jar, the location of jar file slash jar file name. So like the way we see on Linux when we are doing our map reduce function, we talk about the jar file. So now you specify the location of the jar file and the file name. Like when you, for instance, when you are importing a particular package, and you say, okay, based on this package, or this is the class I would like to import. So, but now you're importing, you're showing the file location and the file name. So another thing we need to do is creating what we call the user defined function. So, so after adding the jar file, we create, let's say, the name of the function is temporary function. So like, no, the type of the function is like, okay, a temp, we'll call it a temp function. But what we do is, okay, to uppercase. So the name, what the function does is it puts it when you pass a string or when you pass a variable into the function, it returns uppercase. So this is the name of the function to uppercase, and you have the Java class location and dot the class name. So and we'll see this better in our class. So I also have the defined function. So when we want to call this function now, you see to uppercase. So because you've added a particular function from, I said, like the way this guy would do the normal Hadoop environment, whereby you call the Java file and the class name same. So same here. So just once you call the class name, so it is the class name that you are calling as to uppercase, and you can call the to uppercase Java function and you have your results. So write the user defined function to convert the first letter of a word to uppercase. So in this case now, that means you need to write a Java case, Java code that would just come in and say, okay, only turn the uppercase into, only turn the first letter into an uppercase. So I know if you Google Java code for creating, we call it init cap. I know you guys are familiar with that word. Init cap is just like make all initial word capital, so you can see materials on creating what they call init cap with Java. So that's one, that's fine. So another thing we would like to work through is the joins. Now, can somebody tell me how join works? Somebody's owing me. Oluwatobi, tell me how joins work.
Okay. Join. So there are different types of joins. But the idea of join is if you want to join a party, if you want to join two tables with a common primary key, and by common primary key, I mean a particular column that is present in table 1 and also present in table 2. And then there is inner join. Inner join is basically okay, in the common column, whatever is present in table 1 and also present in table 2 is what is going to show for the inner join. While for the left outer join is all that is in the left table and all that matches what is on the common table, yes, is going to show for the left outer join. And then for the right, hello? So what do you say?
I'm with you.
And then for the right outer join, it basically shows all that is in the right table. and then the common column from the left table will
Okay.
join.
All right. Thank you. I think now you've paid your debt.
Okay.
So that's that. So it's just as simple as what she said. Inner join. What is common? Just that when you go to W3 school, they will say inner join is something like A and B intercept. So that is just using set notations. And when you talk about left outer join, so just like A union B, let's say A union B complement A union B. I'm trying to think about the set notation. Say A union B. A union B. Or what do you say? Or
Which
A A
or which one?
intercepts. Yeah, left outer join. So A intercepts B complements. Yeah, something like that. So wherever you have, we only
They are
have
going to be some A union A intercepts B.
A union A intercepts B. Okay, fine. So I just need something that will just take out B only. Like so, just like everything you have in A is our fixed table. So you join everything that matches A to it and fine. So and right after join, full after join, bring everything. Likewise cross join, just select everything. So all these things are super simple, super simple. I don't know why they call it advanced. So maybe this is advanced. So what is? I don't know. So now Ross is trying to read and write files to HTFS file. What are different classes provided in NICE for accessing different files? How do we access different files? So classwork. Okay. Oh, I think you need this guy for practical class. So okay. I best practices. So what are the practices? We talked about last week. We talked about partitioning. We talked about bucketing. So now best practices: dividing data into small partitions to make it manageable. The normalization, I does not require normalization to avoid complexity. So now, what do we call denormalization? So denormalization is just the act at which on a particular table you avoid multiple record per primary key, whereby you have one primary key and that primary key is having multiple entry. So it is not an efficient way to work with the relational database. So we have what we call efficient use of a single scan. Using single scan for all queries is efficient. So single scan, like what we did when I was using having, is a single scan is best than when you make use of select and select. Use of bucketing, distributing data into user-defined cluster by calculating hash code. So apart from this point, effective use of compression is also one of the I best practice. So uh so now we have what we call performance and query optimization. So how do we optimize our queries? Because there are times you run a query and it takes hours before it takes hours before it drops. So, but there's a need to optimize our queries. So you understand this when you guys are deployed. I can't wait when you guys are deployed to industry. They say, okay, oh, you guys go and work with Eddie, or some of you go and work with him, and I'll work with this person. Whereby you see industry experience and you see how interesting it could be. And so I something happened this morning whereby we ran a query and okay, we ran the procedure, and the procedure took like I mean, I said it's like 1 hour, 12 minutes thereabouts. and I'll feel like, okay, it looks not too bad, but we need to find a way to optimize it. And by the time we finish optimizing, the script that runs for 1 hour, 12 minutes, now runs for 12 minutes. So it's these are normal procedures you work with when you get to the site to optimize your procedures. So turning or optimizing Hive query require understanding how a Hive query works, and that is it. How does it work? So so when you understand how a query works, you know how you can tweak it to run faster. The my notepad I shared with you, because I understand how queries work, I understand that using a halving function is best than using a double scan function. Say, let's say I'm writing a select on select. So because I understand how Hive query works, so I said to know about the working of Hive queries, the explain command is used. So usually the output of the explain command consists of three parts. We call the abstract syntax. So it's just something we call help. So normal programming language say help. So this guy calls it explain. So and it has three main parts, which is called the abstract syntax, different stages dependency, description of each stages. So when you go through the explain of when you try, let's say I'll call it I'm calling it help. So when you go through the help function of a particular syntax, you'll be able to see how it moves from one stage to another, and you know how that function really works. For instance, I said the limit command restricts the output of a certain number of rows, but only after it has processed the complete result. To optimize this, I allow setting of some parameters that are shown in the table. So you said one of the parameters you can set. Now, let's go back to what we know. Like maybe if you are running a machine learning model, like say logistic regression, or let me say cat boost, or yeah, let's say cat boost. So there are lots of parameters you can set, but you can all of them, most of them are set as maybe they have default values. And if you understand how those parameters works, you can set them some to false or some to or give it a particular value. Likewise, in Hive, the beautiful thing is that we can also set parameters as well as we know that, okay, when you say select top 1000, before you select top 1000, the system runs everything. And I say, okay, after running everything now, let me select the top 1000. So it's not efficient to work that way. So there's a parameter in Hive that we call limit optimize enable. So with that, it said allow sampling on limit set of files instead of complete source file. So instead of uh, running through the entire table, it just pick top 5 and just samples. So it optimizes the function called limit. So we also have another parameter called limit row max size. It decides the maximum number of rows limit should consider while querying executing the query. So all these guys are optimizing optimization parameters that you can set to true or false. So you also have limit optimize limit file. Decide the maximum number of files being sampled to run limit query. So just on as simple as limit query, you have lots of parameters you can set and you can activate. All right. So and we have different execution types. So we have what we call the local execution, parallel execution, index speculative execution. So they look so well, they look self-explanatory. Talking about local execution. So it's running on a particular Just like it's not considering, it's running the table as it is. Parallel execution. Uh, in so the parallel. Okay, let me talk. Or let me explain something about local execution. For instance, now you want to carry 10 bags of rice. A person wants to carry 10 bags of rice, and you say, okay, okay, carry this. You, let me say, Oluwatobiloba, go and carry 10 bags of rice. I'm like, oh wow, 10 bags of rice. I know, okay, she can't carry it. Even a bag of rice, like 50 kg, and it's going to take time before she solves that. Like goes there one by one. But what about parallel execution? Is when you say, okay, you ask me to carry 10 bags of rice. Ah, well, I will go there and pick it in 10 maybe 10 models as we use in Lagos. And you also call all your brothers. You say, please come and help me, help me, help me. And you call like 10 people to come and help you. And all of them, they just descend on the bag of rice and they start carrying it. And in limited time, they are through carrying it. Indexes is like when you have a directory or when you have a well-defined address on a particular table that makes the select or the query run very fast. And also have what they call the speculative execution. And this is also one of the most efficient way of running queries. So setting Hive execution model local auto to true enables Hive to decide about the need for a local node execution. So because you see mode, local auto. So Hive breaks the job into certain stage that are executed sequentially. Set the value of I executed parallel to true enables parallel execution of a certain jobs. So we use this almost every time because we are running some scripts that they are very heavy and we set them to parallel, say parallel of 20 sessions. So that means 20 guys should work at a time. So I remember there was a time I was working on one of our projects. It's a bank. I won't tell you the name. Then you start asking questions. So, and I was running a script. The script was running on, and the table is partitioned, but I was querying without the partition table. And after running that script, the server of that bank almost went down. The engineering guys that that was in charge need to shout, "Who are these guys?" And what happened then was that script created over 500 sessions in parallel because what I was querying was too heavy, and it was a bad way of querying that type of table, and it almost cost us a lot. So that's the effect of when you are running something in parallel. Like 500 sessions can be run independently in parallel to get things done. Why? Why Hive allows creation of index on column to accelerate execution of a group by command. So that's fine. I know what I'm saying looks like stories for you guys. I can't wait to have you guys on field. It allows speculative execution of data by setting parameter as given. Said parameter is a map reduce, map task speculative, runs more than one instance of map task. Map reduce task speculative runs more than one instance of reduced task. So the first one is map, the other one is reduced. So it helps run stuff in parallel and makes the job run very fast. So do you have any questions before we go to part B? Any question? Am I in the right class? Hello?
Yeah, I can hear you.
Okay, any question?
No question.
Is anybody having question? No question. So you see it's simple
Yes,
like
I do.
yeah, see, very simple. Please give me 1 minute.
Hello, sir.
Hello?
I have a question.
You have a question? Oh yeah.
Oh, okay, so you made mention of while running a query with a bank and it created almost 500 sessions. So is that, can we say that is a shortcoming of parallel, um, or what do you call it, the parallel this thing that you explained? Can we say that is a shortcoming of
No,
it?
no, it's not a shortcoming. So it's never a shortcoming, and it is also an optimized way of running it. So now, what happened in our own case is that so if your resources parallel, let me say parallel sessions, it buys it consumes a lot of resources. It makes use of all available resources on the database or probably on yes on the environment. So what the implication of what I did, what the process did was that there are other sessions, there are other applications running on that server. But when I ran like 500, when I initiated the script, that script alone consumed all the memory on that server. So which which prevented other applications from running. So to manage things like that, what we do is that we limit the sessions. So when you want to initiate a code, just say, okay, see, parallel should be equal to 20. So it will only initiate 20 sessions. So maybe I think the action point they took was that, okay, on our user, they limit us to just 50 sessions. And that is what they should do. And that's the action point. Even Blessing said, when he was working with MTN, they only give you one session. It was because we are too used to those guys and they gave us open-handed. But normally, when you are initiating processes like this, you can cap the sessions. How many number of parallel sessions should you have? Because when you make it unlimited and the table you are running is too large, it can distort other operations. So it is not um, it's not a disadvantage to parallel sessions, but it lies in the hand of the data engineer to always cap it and set a limit to it. So that's that. So you guys give me
Okay,
more
sir. Thank you
minutes.
very much.
You're welcome. 1 minute. I don't take water. Okay. Um, I'm back. So we want to talk about another thing we'll be talking about is the hash file and record format. So text files, input. We have the text input format, and we have the output file. The input format for the text is like a map reduce function. So you understand that the output of a map reduce function is always can always be inserted into a table. So the input format for Hive also can come from a map reduce, as we know that Hive is just translating Hive. Hive is just translating map reduce into what we call SQL, structured query language. So the background is still a map reduce function. So also the output formats, you see the test output format, which can be in any kind of format. And we also have what we call sequence files and the RC files. We are going to be talking more about that soon. So the record format, we have what we call the reject format, the AVRO, the ORC, and the traits. So Sadi holds the logic to convert unstructured data into records and is implemented using Java. So when you have unstructured data and you need to load it, there's an application that runs our record formats, our SADI. So these guys, all these guys, the reject, the Avro, the ORC, the thrift, they are guys that fix formats to a readable format. Like they convert structured data or structured data into a record and it's implemented using Java. In addition, Regex and Avro SADI's Java objects notation is a standard command that uses readable text to transmit data objects consisting of attributes value pair. JSON SADI is used to transmit data between application. Has anybody worked with JSON file before? You know, have you seen a JSON structure before? A JSON file?
No, sir.
No. Okay. Come in. So, I want to see if I can see one. But so those of us that will work with Python, it is just like talking about a list in Python. I want to share just something. So now JSON file looks something like this, where you have your variable name and the option. So SQL, Hadoop or Hive can take record like this. So most of the time when you see when you are deploying a model, you will say make it in JSON file. When you say the real file in text, you see that it is just assigning values to values or probably working around some programming codes. But it's very simple. When you say JSON file, you can easily read through and understand what is happening. But it is always well defined. You see the variable, you see the options, you see different levels you have, you see attributes and lots of things around in your JSON file. So it is like you can write a whole table as a JSON file and transfer it from one DB to another. So that is one of the peculiarity of Hive SQL. So the JSON service can be used to transfer file from one application to the other. With that, it enables other applications to interact with JSON with Hive. So So he said the JSON study is used to transmit data between applications. So because of the well-structured formats of a JSON file, it makes other applications interact with it. And I think most applications can interact with Java files. Okay, so the features of the JSON study said read file stores in JSON formats. So, like in this case now, coming into Hive environment, the JSON study can read. It's not necessary you read files in CSV. I know Oracle or MySQL they read file like CSV file, uh, but when you're working with Hive, you can read JSON files with the JSON study. So that guy is the guy responsible for bringing in or for reading JSON files format and making sure it is well structured. And when you have those records loaded into a table, it will be hard for you to discover that it is a JSON file. So, and also the features of JSON file support complex JSON nodes such as arrays and maps, and that is all you always see in a JSON file. Support nested data structure. So we talk about nested data structure and a very complex data structure. The JSON study supports that. Convert processed data to JSON, and that is interesting thing. So a whole table can be converted into a JSON file. So record using the insert into command. So the JSON study can be used by performing the following steps. We have step one, you build the JSON study source code and create a jar file. So in practical class, we'll understand this guy more. So I'll just keep this. So, so previously we talked about the features of JSON study, and we'll be talking about the Hive thrift. So there's another service that makes Hive process more interesting and more easy, that can make it more interactive with other applications. We call it Hive thrift service. So Hive thrift service are run on Hive thrift server to which the following clients can connect. So this is interactive. Okay, let me see. In when you're working on let's say production environment, you discover that there are different connecting tools. We have JDBC. JDBC is like Java database connection. We have the Oracle database connector. We have the Python. We have the PHP. So how these guys can communicate to Hive is through what they call the Hive thrift service. So that's the guy that welcomes the connection of these guys. So if they are installing maybe any third-party application and you want to use it to connect to, let me a case study whereby you want to connect a particular third-party solution to Oracle, you need to install what they call ODBC so you're able to connect to it. So, and some applications they require you use what they call the JDBC Java Database Connector, and applications that make use of JDBC is what a software called Nine, and that's our machine learning tools at Octave Analytics. So, and your normal Python and PHP. So this guy enables those applications to talk to your Hive environment. So I think code building sample. So to Akomolafe and Ebube, you guys need to go through this code and understand. In case you have questions, it's either hi or Temilola. Anytime you guys are having your particular question, ask questions that this class can sync. Okay. Um. So now, almost towards the end of the class, what we call the security in Hive. So there's also a security that comes with Hive. So Hive security is primarily a matter of two concepts: authentication and authorization. So authentication is that setting Hive file or mask value, decide the default permission for newly created items, while setting Hive metastore authorization storage checks to true examine whether the user has the permission to drop the table in Hive. Likewise, authorization can be added in Hive. So we see authorization. Authorization is like you are permitted to do something. Authentication is that okay, now you are good to go. So I would say under authorization like privileges, authentication is when you are saying okay, I want to come in. Okay, check. Are you authorized? If yes, okay, it's authenticated. So now the normal basic English we use for authorization and authentication. So but we have something on our security, we call it privileges. So these are privileges that a particular user has on a particular table. So when you have different privileges like all is like you can do anything on that table, all. Just like create, drop, alter, remove anything. And you also have what we call the create privilege. Please 1 minute, I need to pick a call. So sorry. Oh, sorry for the break in transmission. Office work calls. So as I'm saying, I said we have privileges that a particular user can have, and you see the description of those privileges. So all operations to do everything, and you have privileges to create tables, drop, alter, and the likes. There's a privilege called select. So for critical tables, for example, now the transaction like the current project, one of the projects I work with a bank on their transaction table, the only privileges we have on that table is select. We can't do any other thing. We can't run. We can only view what we have inside that table. So that's what we call the select state. Yeah. So we can't alter anything. We can't create anything. We just view what is there. Okay. So I want to run very fast because I was told I have a meeting for 2:30. So the next 5 minutes. So, but at least I like to run you guys through. So, point to remember: the most common operation in SQL is your select statement. We have The built-in function and user-defined function, which we call in by a Java function. I think the example we had in this class is to uppercase function, and your Hive supports normal arithmetic, mathematical function, and the aggregation function like max, mode, and the likes. So I have to support the limit clause. We talk about the limit, which with which you can restrict the select statement. Talk about the inner query. We talk about the case. We talk about the like and the likes. Talk about support joining. Yeah. So also the inner join, the outer join, the left outer join, and the likes. So and map side joins are recommended when you need to join two tables in which one table is smaller than the other. So that's another thing we need to put in mind. The concept of partition in Hive helps in maintaining new partition for every new day without too much effort. So you can automate your partition. So whereby when you set a partition on a particular variable, as soon as you have new entry into that variable, the partition creates on its own. I know we talked about that when we have auto partitioning enabled. So Hive does not have any primary and foreign key because it's not meant to run complex relational queries. So it's something very simple. It's like, oh, please, I don't want to do the big work. But you can transfer data from Hive to, you can write complex queries, but you not with SQL. So you can, it's not that you can write complex queries, but not with SQL. So by keeping the normalized data, you avoid multiple disk seeks, which is generally the case when there are foreign key relations. So I know you guys have this in your
Sorry, can
you
you go
call
to
it,
the previous slide?
what do you say?
Can you go to the previous slide, the slide 8? There was something I missed there. I just wanted to.
Okay,
Yeah, thank you very much.
all right.
Getting it.
So so we have this uh the partition and the likes. So and I also said something about the explain that tells us the description of a particular function and the expected output. And I think after this is what we talk about the optimization of, of a particular script. How do we optimize it? And we talked about parameters that even we can set in the limit functions so as to optimize the limit function um, query and lots. So and I know you guys have all this in your data set in your material. Please go over it, especially the engineering guy. Please go over it in case you have questions. You can ask in the class. So I would like to ask for apology. I'm having another meeting for 2:30, and this is just 1 minute to 2:30. So are you guys permitting me to call it a day? Hello?
Yes, sir.
Yeah. So thank you very much.
Bless you.
Possibly if I will be the one taking you Wednesday, I hope so. Or if not, maybe we go practical. So no wala. So you take good care of yourself and enjoy the rest of your day.
Bye, sir.
All right, thank you.
Are you guys active?
It will be auto.
Are you active? It seems like everyone is. this now. All the class.
Oh yeah,
You said?
I was only answering you that way.
Oh,
So
okay.
what
Daniel, what do you say?
I didn't know you said that. I was asking if you could repeat what you said, please.
No, I was just asking if you guys are still here. Like, it seems like everyone is just quiet now.
Okay, just to confirm, please.
Oh,
Like,
ah,
right?
I didn't know.
But Nicole.
Yes, I'm on the call.
So the class is by 6, not 8 p.m. today, right?
I don't. I think we should do it by 7. What do you guys think?
Let's just conclude. So I'll not
The
plan
reason why I'm
on.
saying so is because office is closed. I don't know. Can we leave this meeting? Let's leave the
Yeah,
meeting.
sure. All right.